Good evening, students. Are you able to hear me?
Yes, sir.
Right. So we'll proceed with the topics that we'll continue with the topics that we were reading yesterday. So, is there any doubt from yesterday's class, guys?
No, sir.
Okay. So this example 11.1, they're saying show that the coefficient of areal expansion, that is delta A by A into delta T, of a rectangular sheet of solid is twice its linear expansivity alpha 1. This we proved it yesterday, right? That what they're trying to say is coefficient of areal expansion beta is equal to 2 times alpha is what you're supposed to prove. So this we have already dealt it yesterday. Secondly, there is a blacksmith who fixes iron ring on the rim of a wooden wheel of bullock cart. The diameter of the rim and the iron ring. So the diameter of the rim and the iron ring are 5.243 and 5.231 respectively at 27 degrees Celsius. To what temperature should the ring be heated so as to fit the rim? So diameter of rim is equal to 5.243 meter. Diameter of iron ring. Right. So temperature is 27 degrees Celsius. To what temperature should the ring be heated? So ring is there. No, ring is having a diameter of 5.231. So you can heat this ring. When you heat it, what is going to happen? It is obviously going to expand, right? You can heat it in such a way that it should be able to, so as to fit the rim of the wheel. Means it should exactly stop at a diameter of how much value? 5.243. You're able to understand?
Sir,
Tell me.
sir, it should be slightly greater, right? Or else how will it fit inside?
No need, exactly will be sufficient. They'll apply grease or anything. That's so the meaning of the question is you need to exactly take it to this value. Okay, exactly fit it into that.
Okay, sir.
Yeah. So 5.243, that is diameter is length, no? Final length is equal to initial length into 1 plus alpha into delta T. So L final is how much? 5.243 is equal to L initial is 5.231 into 1 plus the value of alpha for the iron ring will be given here. The value of alpha for iron material is here. Actually, they are supposed to give it to the example. It is 1.2 into 10 power minus 5 Kelvin inverse. So that's what they have written. 1.2 into 10 power minus 5 into T minus 27. So remember, 1.2 into 10 power minus 5 Kelvin inverse is the same as degree Celsius inverse also. Okay, because dimensionally, what are you going to get? The dimensional formula of 1 divided by temperature. Dimensional formula of temperature. So 5.243 is equal to 5.231 into 1 plus okay. So 5.243 divided by 5.231 is equal to 1 plus 1.2 into 10 power minus 5 into T minus 27. This 1 will come to the other side, and then when you solve it, you will get the value of temperature as 218 degrees Celsius. Means you need to increase its temperature, you need to take the temperature of the material from 27 degrees Celsius to 27 degrees Celsius to 218 degrees Celsius for this kind of a scenario to take place. Okay. So here my main objective is to explain how to solve the problem. Calculation, I'm leaving it to you because of time constraints.
Sir.
Tell me.
Sir, so we don't need to convert the Kelvin inverse into degrees Celsius?
No need, no need. Both are same, no? Because see, what is alpha? Alpha is delta L divided by L into delta T. So delta L is in meter, L is in meter, cancel. So you're left out with delta T. Whether you write delta T in terms of Kelvin inverse, whether you write delta T in degrees Celsius inverse, it is going to be the same because the logic is very simple. See, if I give you two temperatures, I'm talking about delta T, I'm not talking about T. I'm talking about delta T. Delta T is T2 minus T1, correct? So if I give you 27 degrees Celsius and 40 degrees Celsius, so what is the difference between these two?
13 degrees.
13 degrees Celsius. Now convert this to Kelvin. 27 degrees Celsius to you. What will you do? You'll add 273 to it. So it becomes 300, and you'll add 273 here. It becomes 313. The difference between these two, 13 Kelvin.
Okay, sir. Got it, sir.
Got it? Because you're adding 273. But whereas had it been in terms of Fahrenheit, then you should have done it.
Okay, sir.
Yeah. So this is the first part of the chapter, that is thermal expansion. So we discussed majorly about the thermal expansion part. Now we will be discussing the next topic, that is the specific heat capacity. Okay. So these terms that we are going to discuss now are very, very important in terms of thermodynamics. Okay, we'll be learning thermodynamics in physics as well as in chemistry, but the difference is going to be slightly. Okay, but the difference is going to be about, in chemistry you'll be learning more about the concept of entropy and how the reaction is taking place, whether it is exothermic or endothermic, because chemistry is concerned about reactions. Whereas in thermodynamics, physics, we'll be concerned about how much work you can extract with the help of heat. Okay, so for you to understand those basics, that is the next chapter, the basics in the next chapter, we need to ensure that this topic is mastered. Okay, so please concentrate. If there is any doubt, get it clarified. The name is specific heat capacity, or it is also called as specific heat. So specific heat capacity or specific heat capacity or specific heat both mean the same. Okay, any idea before I start? I'm not sure. I'm not sure, but I'm guessing you would have heard this word in your lower grades. Have you heard this word? Have you ever heard this word? Any idea of what is specific heat capacity? At least any guess? No idea? Listen, suppose I have a material in my hand. Okay, let's, for the time being, let's say it is water. Okay, so this water is going to be, let's say, at 20 degrees Celsius for time being. Now, my job is to increase its temperature from 20 degrees Celsius to 21 degrees Celsius exactly. So I'm having a thermometer to monitor the temperature. Okay. Are you guys able to understand till here? No. From 20 to 21 degrees Celsius, if I'm supposed to increase the temperature, what am I supposed to do? You need to supply heat. Right? So you need to supply a specific amount of heat to ensure that the temperature which was initially at 20 degrees Celsius is exactly taken to 21 degrees Celsius. Correct? So for that, will you be able to calculate that amount of heat which is required? Yes or no? Yeah. So if you're able to calculate the amount of heat required to do what? To required to raise or to change. I'll not use the word change, raise. To change the temperature of unit mass. So here, one more important word I need to mention here is we need to take unit mass of a substance. Unit mass means 1 kilogram or 1 gram of a substance. So unit mass of a substance by 1 degree Celsius or 1 Kelvin. So try to understand the story. Don't be concerned about the definition. You will understand it. So you take 1 kilogram of any substance, and that 1 kilogram of any substance is going to have a specific temperature. And you want to raise the temperature of that substance by 1 degree Celsius or 1 Kelvin. Okay. Then you need to supply heat. If you're able to calculate that amount of heat which is required to change the temperature of unit mass of a substance by 1 degree Celsius or 1 Kelvin is what we call it as specific heat capacity. Am I clear with this definition?
Yes, sir.
Right. So generally specific heat capacity is represented by the symbol S, or sometimes it is represented with the symbol C. Okay. So mathematically it is written like this. The amount of heat, that is delta Q. Q is represented by the symbol, sorry, heat is represented by the symbol Q. The amount of heat required to raise the temperature of unit mass of a substance. So whenever the word unit comes, right, you should write it in the denominator. Unit mass of a substance through unit temperature difference. Okay. Delta Q divided by M delta T is the mathematical equation for specific heat or specific heat capacity. Okay. Now, the question is, what is going to be the SI unit of it? Joule per kilogram per Kelvin. Joule per kilogram per Kelvin. Then what is going to be the CGS unit of it? It will be calorie per kilogram per degree Celsius. So remember, I would have told you that the unit of energy is erg, but the unit of heat energy in CGS unit is calorie. So have that in your mind.
Sir, it will be grams, right?
Oh, sorry, sir. Yeah, it is gram. Calorie per gram per degree Celsius. Or gram into degree Celsius, both mean the same. Okay. So write it down. 1 calorie is equal to 4.2 joules. So the meaning of it, you would have heard this, right? When you work out and do all those things, you burn out calories. Right? You would have seen behind the food packets also that the calorie count would have been written, but that is actually not calorie, it is kilocalorie. Okay. So what does this tell us? So if you want to burn 1 calorie of energy, then you need to do an equivalent work of how much value? 4.2 joules. Am I clear with this definition, guys?
Yes, sir.
Right. So this is called, see, the reason I'm stressing so much is because there are some other specific terms also that are going to come. You should not get confused. So now what I discussed is specific heat or specific heat capacity. Now there is something called a specific heat capacity with the prefix called molar attached to it. So molar is derived from the term mole. Now what did I say is the amount of quantity that you need to take to define specific heat capacity. What is the quantity of substance you need to take to define specific heat capacity? I just now told you. You will take
Mass.
unit mass of a substance. How much? Not mass, it is unit mass of a substance. Similarly, if you have to define molar heat capacity, instead of taking unit mass, you need to take unit. Can you fill the gap? Unit dash. You need to take unit mole of a substance. Are you able to understand? So molar specific heat means it's almost the same definition. The amount of heat required to raise the temperature of unit mole of a substance through a temperature difference of 1 unit. You're able to understand? Delta Q divided by mu into delta T, where mu represents the number of moles. This is the one which we'll be dealing in the next chapter. Molar specific heat. Am I clear, guys? So SI unit is going to be joule per mole per Kelvin, and CJS is going to be calorie per mole per Kelvin.
Sir?
Tell me.
Sir, even the representation of molar heat capacity is also C.
Here they have mentioned it like that, but yeah, generally it is C only. C generally for molar specific heat, right? In the next chapter when we discuss, we'll be discussing under two conditions. We'll be talking about molar specific heat under constant pressure or molar specific heat under constant volume. Okay. So we generally write it as CP or sometimes we write it as CV. Sharia. So C is the symbol used, but you need to use a prefix in addition to it, because I need to mention. So that is why I told you this will be dealing in depth in next chapter. Okay, as of now, don't worry. Try to concentrate on the definition. Definition is clear, right?
Yes.
You have a clear differentiation between what is specific heat capacity and molar specific heat capacity. Yes? Just tell me an yes or no.
Yes, sir.
Yeah? Yes, that is enough for me. Now, I'm going to define a third term, which is called as heat capacity. So, specific heat capacity is over or specific heat. Then we have molar specific heat capacity. The next thing that we are going to discuss is called as heat capacity, or the other name for heat capacity is thermal capacity. So this definition is also almost similar. I will write the mathematical expression. You guys try to define it. Delta Q divided by delta T. Whereas here it was delta Q divided by M delta T. Here it was delta Q divided by mu delta T. What is the difference between these three?
Sir, the first one is amount of heat required to raise the temperature of 1 degree Celsius
Unit
or
mass of
Kelvin
unit
or
mass of
unit mass.
unit mass of a substance. Here it is unit mole of a substance. Then here what is it? The amount of heat required to raise the temperature of. It is also amount of heat required to raise the temperature of any mass of substance. Means if you have to define a parameter called as heat capacity, you will not be concerned about mass. Whether you take 1 kilogram of water, 2 kilogram of water, 3 kilogram of water, you can define a quantity of quantity called as heat capacity for that material, heat capacity or thermal capacity. But if you want to define specific heat capacity, then you need to be particular that you need only 1 kilogram of that substance. Are you able to understand the difference? There is a very, very, very slight difference. It's a thin line, right? Here it is unit mass of a substance. This one says the amount of heat required to raise the temperature of any mass of a substance through unit temperature difference. Clear? So here the SI unit is going to be joule per Kelvin and the CGS unit is going to be calorie per degree Celsius. Suppose I give you the heat capacity as 4.2 joule per Kelvin and I say mass of the substance is 2 kilogram and I ask you specific heat capacity. What will you do?
Sir,
So
2.1.
So heat capacity is equal to mass into specific heat capacity, correct? By now I am assuming you would have figured it out. So 4.2 is equal to 2 into specific heat capacity. So specific heat capacity will be how much? 2.1 joule per kilogram per Kelvin. Right. So this is another important relation that you need to have in your mind. Right. So shall I move on to the next question? Sorry, next topic. Please tell.
Sir, we know that in chemistry we learned like Cp minus Cv will be given or
R will be equal to R, universal gas constant. Yes.
yes. So here
that only.
what are you talking about? Like heat capacity or specific heat capacity?
They spoke. So in your chemistry, I've learned, right? Cp minus Cv is equal to R. Right.
Yes.
That Cp and Cv are molar specific heats under P stands for constant pressure and V stands for constant volume. Only thing is, you would have. I'm assuming that you would have not seen the derivation of it. If I'm not wrong, correct? They would have told you that this is the formula applied, correct? No, that's how chemistry works. It's not. That's how the subject works. Am I right or wrong? Or was the derivation shown? Is it given in textbook? Yes or no? Not sure?
Sir, I
At
think
least
it's given, sir.
it's given. Given means just go through it once. Go through. It's a simple derivation. It's very, very, very simple derivation. So Cp minus Cv is equal to R, where R is a universal gas constant. Okay, that is also called as Mayer's formula. We'll see it in 12th chapter. So that Cp, since you asked me, I'm telling you, it is molar specific heat under constant pressure.
Okay, sir.
Yeah. Because in chemistry, we'll be dealing more with moles, not with this thing, mass. Right. So the next heat that I need to discuss is latent heat. Okay. So I introduced this term yesterday itself. This happens when there is a change in phase of a substance. So if you take a solid, then liquid, then you have gas, right? So solid, when you supply some heat, it gets converted to a liquid. Liquid, when you supply some more heat, it gets converted to gas, right? Especially if you take water, then water can be in the solid form when it is ice. Okay, so if you have to melt ice, what do you mean by melting? If you have to melt ice, then at what temperature can you do that? You can do it at 0 degrees Celsius. If you want to vaporize water, This you can do it at 100 degrees Celsius. Okay. So yesterday itself, when I mentioned it clearly that when ice is melting, when you supply some heat, you will be supplying some heat. But that heat will be utilized only to do what? Only to break the bonds in the solids and convert it into a liquid form. Correct? When this kind of a conversion is taking place, we call it as melting, where a solid is getting converted to a liquid form, and that heat is utilized only to break the bonds, and that heat is not utilized to raise the temperature. So that kind of a heat which is used only to break the bond or change the phase of the substance is what is called as latent heat, because latent means hidden. Okay. So the formula for latent heat is something like this. It is the amount of heat required to change the phase of unit mass of a substance from one form to another. So how is it defined? It is the amount of heat required to change the phase of unit mass of a substance, to change the phase of unit mass of a substance. That's it. Heat required to change the phase of unit mass of a substance. When I say phase, it can either be solid to liquid or liquid to solid. Similarly, it can be liquid to vapor or vapor to liquid.
Sir.
Tell me.
Sir, so if it is vapor to liquid or liquid to solid, then L will become negative.
No, it will not be negative. Because it can be amount of heat requirements. It can either be amount of heat that is being supplied or amount of heat that is being extracted. Okay, you're able to understand?
Okay, sir. Yes,
Yeah.
sir.
So when will solid get converted to liquid? When you supply heat. When will liquid get converted to solid? When you extract heat. Okay. So based on this process, there are two kinds of latent heats that are defined. So latent heat is basically classified into two types. One is called as latent heat of fusion, and the second is called as latent heat of vaporization. Okay, because these are the two phases. Fusion means ice combining together. So whatever is the energy that is extracted for that ice to be formed will be the same amount of energy that you need to supply to convert it to a liquid form. So that's why it is called as latent heat of fusion, and the other is called as latent heat of vaporization. So wait for some more time, you will be able to understand things better. Okay. So going on to the next part, that is calorimetry. So calorie is derived from where? Calorie is derived from the unit of heat. Metry means what? Meter, metric. It's basically a measurement. So if you have a particular branch in your hand, right, which is specifically going to concentrate only on the factor of calculating heat, then that kind of a branch is what is called as calorimetry. And the device which is used for this kind of a process is what we call it as calorimeter. A device in which heat measurement can be made is what is called as a calorimeter. Are you able to understand this point, guys? Yes or no?
Yes, sir.
Right. Now, there is an important theory that is called as the principle of calorimetry. So, principle of calorimetry states something like this. If you have an isolated system, what do you have? You have an isolated system. What do you mean by isolated system, guys? Any idea? So, isolated system is basically a system where no exchange of heat takes place. Basically, it's an adiabatic system. Okay. So this is what is an isolated system. If you have an isolated system, then you can say amount of heat lost by a substance will be equal to the amount of heat gained by another substance. So what I'm trying to say is, sorry, the amount of heat gained by another substance. So what I'm trying to say is, let's say you have water, okay, in which you have put some ice cubes. Let's say those ice cubes are at 0 degrees Celsius and this water is at 20 degrees Celsius. So which one is at a higher temperature? Obviously water, which is at higher temperature. So we know the fact that heat starts flowing from an object of higher temperature to lower temperature. So if heat starts flowing from water to ice, what process would take place? So this water will start melting the ice. Correct? Water will melt the ice. Let's say it is happening at 0 degrees Celsius itself. After water has got converted, so after the ice has got converted to liquid form, at least some part, not let's say this much ice is there, this much part has got converted to water. Let's assume. Okay. Then what will happen? Then the water that has got converted will start having a rise in temperature. Where is the rise in temperature happening from? It is from the hotter substance. Because hotter substance has the tendency to transfer heat to the substance at lower temperature. So when it does it, the temperature of the colder body is increasing, means the colder body is gaining heat and the hotter body is losing heat, and this process will stop when there is something called as thermal equilibrium that is attained. So what do you mean by thermal equilibrium? When these two materials have a constant temperature. So that is the principle of calorimetry. So why I use the word isolated system is because in the system it was only water and ice that were in contact. So if the ice is melting or if the ice is if the temperature of the ice is increasing, everything should happen only from this 20 degrees Celsius that is available within the system. It should not come from the surrounding. If that comes, then that is not called as the principle of calorimetry. Okay, so this is the most important point. The amount of heat lost by a substance, which substance will lose by a hot substance, is equal to the amount of heat gained by the colder substance. Is this clear? This is a very, very, very important rule, because problems are solved based on this principle only. If you're clear with this principle, now my job is to make you understand the problems. Are you clear? Shall I proceed?
Yes, sir.
Right. So listen to this. So with this theory, from the second part is also over. That is, the first part is about thermal expansion, second part is about calorimetry, and the third part is about heat transfer. Okay. So now we will do some problems which are based on calorimetry. Read the question carefully. There is a sphere of aluminium of mass this much value. So mass of aluminium is how much? 0.047 kilogram is placed for sufficient time in a vessel containing boiling water, so that the sphere is at 100 degrees Celsius. Now the temperature of aluminium is also 100 degrees Celsius. It is then immediately transferred into a copper vessel of mass 0.14 kilogram containing water. Mass of water is 0.25 kilogram and the temperature of water is how much? 20 degrees Celsius. The temperature of the water rises and attains a steady state at 23 degrees Celsius. What do you mean by steady state? Means the temperature of water has
Equilibrium.
increased from 20 to 23 and that process is stopping. But where is it gaining that 3 degrees Celsius from?
From the
Where is
aluminum.
it? From the aluminum, right? And attains a steady state at 23 degrees Celsius. Calculate the specific heat capacity of the aluminum. So this is our job. Right. So how to solve this? temperature of water is, did they give the temperature of this thing? One minute. So that the sphere is at 100 degrees. It is then immediately transferred into a 0.14 kilogram copper calorimeter containing 0.23 kilogram of water at 20 degrees Celsius. Now, what is the initial temperature of the system? What is the initial temperature of the system?
20 degrees.
It is 100 degrees Celsius. What is the final temperature of the system? It is 23 degrees Celsius. So temperature final of the system is 23 degrees Celsius. So what is the job? We need to calculate the specific heat capacity of aluminum. So delta Q, right? The amount of heat is lost by the aluminum. The amount of heat lost by the aluminum is equal to how much? The amount of heat lost by aluminum is mass of aluminum into specific heat of aluminum into the change in temperature. So what is the mass of aluminum that is there? 0.047 into specific heat of aluminum is what we need to cancel into what is the change in temperature that has taken place. From 100, it has come down to 23. So it is 77 degrees Celsius that this material has lost. Okay. Now, what is the amount of heat gained by the calorimeter? So amount of heat gained by the calorimeter is mass of copper into specific heat of copper into delta T plus mass of water into specific heat of water into delta T. Correct? So they should have given certain values. That is what I'm searching for. So mass of copper is how much? So mass of the copper calorimeter is 0.14 into specific heat. So they should have actually given this value. Okay, in exam, if suppose there is one unknown asked, you ensure that these values are given to you. Okay, you can ask into 0.386 into 10 power 3 joule per kilogram per Kelvin into what is the rise in temperature that has taken place? Initially, calorimeter was at 20 degrees Celsius. Now the temperature has got raised to 23. So the change in temperature is 3 degrees plus mass of water is how much? 0.25 into specific heat of water. This value you can remember. It is 4.18 into 10 power 3. So 4.18 into 10 power 3 into 3 degrees Celsius. So how many unknowns do you have? So the amount of heat lost by the aluminum will be equal to the amount of heat gained by the aluminum under what conditions? Under isolated conditions using the principle of calorimetry. So equate these two values. When you equate, you will have one unknown and one equation. Solve for the specific heat of aluminum. Guys, am I clear?
Sir.
Tell me.
Sir, so change in temperature is always taken as like positive.
Yeah, change in temperature. No. Change in temperature doesn't mean positive. If you're, it depends on what language you're using. So I told the amount of heat lost. The amount of heat lost by the aluminum. So when I say lost by the aluminum, initial temperature would have been greater than the final temp. Initial temperature would have been greater than the final temperature. That is the reason why I took it as positive here. Not like you take it positive always. You're able to understand. So here,
sir, but while solving these kind of problems, we have to take it positively, right?
Oh, you have to take it positive if you mention the word heat lost by the material. Because in delta T, right, the formula is T2 minus T1. You should take positive only, but I'm telling what logic what are the keywords you need to write to the exam. Okay, see, logically, sir. if I take delta is what I told you from the beginning when I started teaching physics. I told delta means final minus initial. So finally, what is the temperature? It is 23. Initially, it is 100. We should have taken it in Negative. But what does a negative sign indicate in this context? Negative sign indicates that the
Amount
heat
of
is
heat lost by the
heat is
system.
lost. That is why I already use the word amount of heat lost. If I use the word lost, then I can take it as positive. If not, you should take it as negative. So that is what so these two things should be balanced is what I'm trying to say. Okay, when you write in the exam, please
Okay,
be
sir.
careful with
Understood, sir.
what? Yes. So you have to equate these two values, one unknown, one equation, solve it, you will get the answer. So that is all about principle of calorimetry. And in tomorrow's class, we will do a problem that is based on latent heat as well. So after this problem is over, then we can go for heat transfer. Okay, guys, listen to this carefully. 1 minute, don't leave. So in tomorrow I have an important meeting in a school. Okay, so I'm not sure when it is going to get over. I'm assuming it will get over by 3 o'clock. But if there is any delay, I might have to push the class slightly beyond 5. So I'm just keeping you posted. Okay, if it goes beyond 5, then I'll tell you what is going to happen. So have this in your mind. That's it. So mostly it might not happen, but if it is about to happen, you will get a notification at least 1 hour before. I'll try to keep you posted. Is that clear, guys? I'll
Yes,
ensure
sir.
that the class is not cancelled. Okay, please be available. That is what I'm trying to say. Yeah, that's it. We can wind off.